Since winter is approaching, we can observe that the sunlight hours are shorter and the light is weaker day by day. That is why plants growing is slowing down during winter period. So having a carnivorous plant from Nepenthes species, we know that it need at least 12 hours of light per day. Since that value could not be achieved using the sun, we must call the technology and use the artificial sunlight. An artificial light source can provide the required energy for growing the plant only if we know what type of color or brightness we choose. Because the light source will be placed in a wet environment, the fluorescent light will be eliminated because they use high voltage. Now we will choose a safe light source powered by DC current LEDs. But what type of LED? Well, looking on the requirements, we see that our light source should have around 4000 lumens. That is why we choose some power LEDs. Searching on internet, we found that in order to grow a plant, it should be exposed to blue light. To make fruits and flowers, a red light can be used. Researching again on internet, we found that the blue spectrum is provided by LEDs with a light temperature between 6000 or 6500 Kelvin. We also find that is a good idea to use a combination between neutral and white light. So that being said, we will search some 4000 Kelvin and 6000 Kelvin LEDs. On the manufacturer website, we find LEDs with power from 10 to 100 watts and various light temperatures. But analyzing the products, we find that LEDs with a power bigger than 10 watts require a nominal voltage between 33 and 45 volts DC, which is harder to obtain from a normal power supply which won't power only LEDs. That is why we choose the 10 watts LEDs, which have a nominal voltage between 9 and 11 volts DC. So we need two LEDs for one plant, and because we have two plants, we will buy 4 of them. 2 with a light temperature between 4000 and 4500 Kelvin, and 2 with 6000 and 6500 Kelvin. That means a total power of around 40 watts, and because each LED can provide from 800 to 1000 lumens, we have a luminous flux of 4000 lumens, which is almost normal. We also need a power supply without which output 12 volts at 10 amps for a long life running time. So we need some also heat sinks, thermal paste, cables, screws. After ordering the components from the manufacturer and receiving them, we can assemble our project. But first of all, we tested the power supply to measure its load temperature and other parameters. After performing the test with 55 watts and 120 watts load, we found that all components are performing good, except the secondary fast diode, which overheats even a small loads. It's why we need to replace it. We will replace the diode with an ultra-fast 30 amps double diode from Toshiba, which after performing the test, it only heats up to 40 degrees, compared with the original one which heat up to 70 degrees Celsius. We also added thermal paste on the semiconductors, new diode and transistors, because it was missing from the factory. After this operation were completed, we mounted two LEDs on a heatsink and tested one of them. We observed that 11 volts it draws around 4.6 amps, which is a very high current compared with 1 amps from the datasheet. That is why we need to add a current limit feature to this circuit. This feature will be provided by a DC to DC step-down converter, which step down the 12 volts from the main power supply to 9 to 11 volts and limits the current. After adding this module and settings it to output 10 volts and 0.9 amps and connecting on the LED from the heatsinks, we observe that the heatsink is getting hot quickly. It gets around 65 degrees and in just 1 minute. With both LEDs on, it's even worse. This means that the heatsink is too small and we need to order a bigger heatsink. We will buy also a larger enough heatsink for all LEDs with the 2 fans for active cooling. We need also some resistor because the LEDs can have some specification. We need to equally spread the current flow to prevent overcurrent from the LED with a smaller resistance. After doing some calculation, we will pick 4 resistors with a value of 1 ohms and a power of minimum 3 watts. We will go with some ceramic 1 ohm 5 watts resistors mounted in a series with each LED. Moving forward, we use the pre-existing holes to mount the LEDs and we make the mounting holes from the body of the LED bigger to fit the screw. Each LED will be mounted with thermal paste to increase the heating transfer rate. Then we test 2 LEDs with a current limit of 2 amps to check the temperature of heatsink. As you can see, the temperature is around 39 to 40 degrees after 15 minutes of working without any fan, which is very good. After that, we remove the test wires, clean the surfaces. Then we solder the resistor and the wires as following: negative wire connected to all negative terminals of the LED in parallel, positive wire connected to all resistor series with positive terminal in parallel. After soldering the wires, we hot glue the resistors and wires and perform a final test with all 4 LEDs connected. The results are following. Without active cooling, temperature climbed to 43 degrees in 10 minutes with a current limit of 3 amps. After we add 2 fans for active cooling and the temperature start dropping. After 4 minutes it was around 35 degrees, constant value. Intensity of light was very strong, the light have mixed properly and all results and measured values were good. So it is time for the final step, drilling holes for mounting sticks. After this step we wire this project with a 7.5 mm thick wires and a special wire for fan connected with screw terminal for easy and fast removing. The project is complete, so it's a time to the final settings and measurements after adding 2 40 by 40 fans from Sunons. The temperature remained constant between 35 and 37 degrees and the moved air flow was a lot. we increase the current limit to 4 amps to ensure the maximum power and glow of the LEDs. The current flow is around 0.972 to 1 amp per each LED. The resistors are at 47 to 57 degrees Celsius. The DC to DC converter is at 50 degree and the power supply is at same temperature. This project is connected through a programmable outlet, so it's turned on at 5 in the evening and shut off at 8:30, and start at 6 in the morning and turn off at 7:30. Newest programs for holidays and winter time from 12 o'clock in the night to 6 o'clock in the morning. And the last observation, we add the aluminum foil and paper panel because the LED was too bright and a lot of lights were escaping outside through the window.